In this video, we will implement lecture number 2.4 in the course of NPTEL CS7015, which explains the concept of error surface. So we will implement the error surface for a Boolean function known as OR. So OR is a pretty simple Boolean function where if both of my inputs are 0, then my OR gate will not fire, otherwise it will. And understanding it in terms of neural network, if both of my input is 0, that means that is the condition for not firing. It means that the weighted sum is less than 0. Otherwise, my weighted sum is greater than or equal to 0. Remember that even equal to 0, weighted sum to be equal to 0 is considered as firing. So this is my decision boundary where my weighted sum is equal to 0. So we will say that if the weighted sum is greater than 0, greater than or equal to 0, it's going to fire. And if it's less than 0, then it's not going to fire. So let's just see how OR function looks like. So this is how my OR functions look like. That is, it's not firing at 0, 0, otherwise it is. So that's why it's green. Now, my decision boundary would depend upon the values of W0, W1 and W2. If I keep my threshold to be same as, that is, W0 is -1, which means the threshold is 1. And if I keep my W1 to be 1.1, W2 to be 1.1, then my decision boundary would look like this. And it means that any point which lies above this line, it's going to fire. So it's going to fire for 3 points, and it's not going to fire for 0, 0, which is what we want. So the error is 0 in this case. But if I change the value of W1 and W2 to be -1, -1, keeping the threshold same as 1, which means that W0 is -1. So my decision boundary shifts in the south side. And now it's going to fire for all the 4 points. So the error is this point, 0, 0. It should not fire, but here it is firing. And if I again change my decision boundary by changing W1 and W2, that is I make W1 to be 1.5 and W2 to be 0, then my decision boundary is horizontal. And now it's going to fire for these 2 points, and it's not going to fire for this point, which means that these 3 points are classified correctly, but it's not going to fire for 1, 0 while it should. So again, my error rate is 1. So it means that we can change the values of W1 and W2 and we can get the corresponding error rate. Okay. Another example is here. If I change the value of W1 to be 0.45 and W2 to be 0.45, then it's going to not fire for all the 4 points. So now error is 3. So if we take different values of W1 and W2 in some range, I'm taking it to be in the range of -4 to 4, then we'll get some where we get 0 error, somewhere we get 1 error, somewhere we get 2 error, 3 errors, or 4. That is when all the 4 points are incorrectly classified. And that case would be, let's see how to visualize it. So yeah. So this is the error surface. So I am adding the error whenever it's going to fire for my first point and it's not going to fire for my rest of the 3 inputs, then I'm adding the error. So see, we can see that the error rate is 0 for the points in the range of somewhere here 1 to 4, where my W2 is in range of 1 to 4 and my W2 is in range of 1 to 4 and W1 is also somewhere in range of 1 to 4, then the error is 0. And when my W1 is in range of -3 to -4 and my W2 is also in range of -3 to -4, then the error rate is 4. That means that all the 4 points are incorrectly classified. So that's the whole implementation of lecture 2.4. Thank you.